Hello. Hope you and your loved ones are safe and doing well in these challenging times. This is our project, which for the presentation we aim to research on and develop on as our final year project. I would like to start by introducing our team members, Neha, Ehsan, and of course myself, Zuhair. Before we move on to our proposal, let me tell you about our motivation behind this project. According to an article on Air Quality Index published on the 8th of March 2019, found on the website aqi.in, vehicle pollution is one of the major contributors to your city's air pollution. Hence, one of the ways to reduce air pollution is to choose fuel efficient vehicles such as electric vehicles. Fuel efficient vehicles promise to help the environment and also saving the cost of the fuel at the fuel pumps. Since EVs are being promoted globally and there are multiple researches going on in this domain, industries and researchers need simulations to test their design. This not only saves time but also their resources and are financially friendly. Third, university programs do not focus much on hardware in loop mechanism and testing, as you will see in the deliverables. Our aim is also to introduce a way by which undergraduate students have hands-on rapid prototyping techniques, interfacing FPGAs with MATLAB and Simulink before they take a step in their industries. Coming to our problem statement, the first problem we came across was that the hardware designs which are under testing and experiments are quite sensitive, and not only that, they can be costly. To cater this, we propose an agile mechanism which eradicates the need for a physical hardware setup. Secondly, the current converters in EVs are controlled by microcontrollers. The disadvantage of using of using microcontrollers are that they have less memory and input-output ports, and due to its sequential execution, it has slow processing speed. FPGAs, however, FPGAs, however, is a programmable hardware with parallel processing capabilities, hence provides faster response for time-sensitive hardware like electric converters. Pakistan is a third world country. Thirdly, Pakistan is a third world country which still needs a lot of working to be done in its EV sector. At present, there is only one automotive company in Pakistan which has officially launched an EV in Pakistan, but unfortunately, due to lack of charging facilities and other resources, it is a struggling sector. It is a struggling sector here. We aim to explore our capability of EV design and modeling in context of Pakistan electrical and power system via surveys, government reports, and discourse data. Last but not the least, we aim to design compatible DC to DC boost, buck, and buck boost converters for electric vehicles in context of Pakistan electrical and power system. With the, with the term with the term compatibility, we mean in reference to voltage levels, current rating, power rating, frequencies, components availability, components for example, FETs, FETs, batteries, diodes, etc. in Pakistan.
Hello everyone, I am Essen, and in this presentation I will be briefly discussing two main components of our final year project. Let us start with the stakeholder analysis for this project. So as Zuhaib has already discussed the problem statement for this project, I will be extracting or primarily discussing the relevant stakeholders from those problems. First and primary stakeholder that we have for this project are the electric vehicles manufacturing companies such as Waymo, Uber, Envoy, and Tesla. Since we will be closely conducting the design, implementation, and analysis of electric vehicles within the simulation tools like Simulink and Typhoon, so we will be researching the data made available by these companies to general public and the technology that is employed by these companies for the manufacturing of these vehicles. In addition to that, our secondary important stakeholder will be the electricity distribution companies within Pakistan, since the prototype for bidirectional converter that we would be intending to design would include certain parameters concerning voltages, currents, and power, which we want to do so within the context of electricity distribution parameters within Pakistan. Since our simulations for electric vehicle will include charging and controlling with the reference from certain parameters for voltages and currents, so we would want to conduct those simulations within the context of electrical grid system within Pakistan and the standards that are used within Pakistan. So we will be analyzing the available data for those parameters made available by the companies like K Electric and WAPTA and NTDC and other such distribution companies, right? So the third important stakeholder would be the undergraduate program coordinator, since one of our deliverables for this project is to introduce basic functioning of FPGA interfacing and concepts of hardware in loop and DC converter designing at an undergraduate level through courses like power electronic system design labs or embedded system labs and other such relevant courses where this knowledge or this information or the could be incorporated, for which we'll be having to coordinate the with the departments responsible for designing and executions of lab within the colleges. Right. So secondly, I want to briefly discuss the project proposal and the current plans that we have for this project. So what you are seeing on the screen is the very abstract and high level introduction of 5 main components. On top, we have FPGA development board, which will be designed to act as a controller for the bidirectional converter that is right below it, and will act as a hardware in loop for a simulation for the electric vehicles as well. The bidirectional configuration for this DC converter is so targeted because we want to incorporate regenerative braking system as well, which will basically allow the flow of power to both sides, from battery to the motor in normal condition for the motor, and from motor to the battery under condition where we will be applying brake or simulating the brake within the electric vehicle, so as to recharge the battery from regenerative braking. So the reason why we will be using FPGA as a controller for our converter is primarily due to its high processing power and clock frequency, as Zohaib has talked about, which basically gives it a clear edge over microcontrollers like Arduino. Right. So the previous slide was basically a summarized block level abstraction of main components identified so far. So so this slide is mainly the concerning the specification of each block. So some part of this model would be simulation based like electric vehicle itself and sensors, while the components like DC converters, battery and FPGA algorithms for control would be targeted to be implemented and designed on an actual hardware. So to briefly explain the exchange in this figure, we will have electric vehicle simulation connected with a DC converter and a battery which will utilize battery for normal driving mode, and will change it under braking mode through regenerative braking mechanism as well. Similarly, there will be some sensors to incorporate the feedback loop for the control of the speed and torque of motors that we are simulating. The signals from these sensors will be taken from the output to be fed into the controller to remove the error that is present within the output. This controller for DC converter, as I mentioned previously, would be something that we will be targeting to design on an FPGA for efficient and precise control. Right. So secondly, I want to briefly discuss the scenario where we will be implementing the whole EV plant within Simulink and interfacing it with the FPGA. So the above block that you are seeing will completely be simulation based, consisting of a battery, converter, motors, and transmission, whereas the control signal is something that we intend to produce through an actual FPGA via real-time interfacing of FPGA with our Simulink model. After that, if we are able to successfully conduct our simulations and the FPGA interfacing control experiment, then we will be moving on to building actual hardware for our DC converter, and will be adding actual physical battery to replicate a scenario of electric vehicle battery charging and discharging under normal mode and under the mode where we will be simulating regenerative braking. Right, so I think that is it from my side, and some of the components, some of the elements for the project proposal that I've mentioned are still in phase of revision. So once they are finalized, they will be discussed within the final deliverable document. Right, so thank you.
All right, moving on to our deliverables and outcomes. Our first and foremost deliverable is to be able to control our bidirectional converter using the FPGA. We have already started working on this deliverable, and we aim to finish it by the end of this month. Our second deliverable is to develop our hardware in loop setup so that we can achieve our aim to provide a rapid prototyping possibility with the controller. We have also started researching on this deliverable, and we aim to get done with this by the end of Capstone 1, inshallah. Our next deliverable will be to develop a PID-based controller of the plant so that we can control our output, speed, and torque of the electric vehicle and calculate its parameters and all. Our fourth deliverable is to design lab manuals of basic intro on FPGA with with Simulink interfacing and converters rapid prototyping. We thought of this deliverable because we are currently taking PESD, Power Electronic System Design, and that course doesn't have a lab. And we think that by introducing these sort of labs for this course would be a good asset for the university and for the students. Moving on, our fifth deliverable is to be able to design a physical hardware DC to DC bidirectional converter. We know that this might not be possible given the COVID conditions, and that is why we have given it a lower priority in our deliverables and outcomes. But if we are able to generate a hardware of this, we will aim to do that. Our last deliverable would be to be able to publish a paper in this area, as we think that due to our hardware in loop component, we think that we will be able to publish a paper in the relevant conferences, hopefully. So these are some of the resources, researches that we have used for the current research that we provided in this presentation. Moving forward, we have also been researching on more papers with regards to our first and second deliverable. And yeah, that is it on our literature survey. And that's it for our presentation. Thank you.